Hi, my name is Daniel, and I'm a partner sales engineer based in Singapore. I'm sure many of you take flights in your travel, and it's never enjoyable when your flights are delayed, right? You have to keep your family and friends waiting for you, and you miss important appointments. What if airlines can better predict flight delays? Well, in today's session, I'm going to show you how you can take some public data sets from our marketplace that consist of flight delays for multiple airlines all over the world, combine that with weather data, to train a model in Snowpark without bringing any data out of Snowflake, and using that model to predict a flight delay and also to find out what are the main causes for flight delays. Finally, building a data application on Streamlit where you can visualize the most delayed flight paths on the map, and also to perform a what-if analysis, keying some real-time parameters of weather conditions in the arrival airport, and find out whether a particular flight is going to be delayed or not. Let's take a look.
To start off, I took a public data set from the marketplace, which is the OAG flight status data that contains flight delays for different carriers. I then enriched the data with hourly weather data taken from a website called Meteostat, which is a global database of weather data for locations all over the world. Then I also uploaded a file that contains geographical coordinates for a lot of the airports all over the world, and also a weather station's reference data in JSON format. The reason for this is because the hourly weather data is based out of weather station ID. So I needed to match the weather station ID to the appropriate airport location. This file provides that matching information. Of course, we are not just limited by weather data. Weather data is just one predictor. In reality, you can have multitude of predictors and factors. For your customer, they might have their own data sets such as flight operations, aircraft maintenance, or crew schedules that they want to add into this model to improve the prediction. All this data is then ingested into Snowflake, where I use Snowpark to perform three things. One is using Snowpark, specifically Snowpark data frame for feature engineering, where I stitch the flight delay data sets with weather data and perform some transformations of the features. And the model training is then pushed into Snowflake by writing them into stored procedures. And finally, UDFs are created to perform inference. Same thing as well, pushing down all the predictions into Snowflake. On the front-end sites, I built two SnowSight dashboards. One is basically a BI dashboard that shows the historical flight, specifically showing which flight paths are the most delayed for a particular carrier. This is not using any machine learning at all. And then the second dashboard actually uses explanations that were extracted from the models to show you what are the main predictors for flight delay and how these predictors correlate with your delays. There's also a Streamlit app that visualizes the flight paths and accepts input parameters from users and combines them with real-time weather forecast API from Meteostat as well, passing them into a UDF in Snowflake to generate a prediction. Okay, let's jump to the demo. First, let's go to the marketplace where we get the data. Search for flight delay. There are different data sets available. The one I took was this OAG flight status data sample here that contains flight status such as early on time or delayed for many carriers for airport locations all over the world. I can easily just get the data here without any ETL, and immediately I'm able to access the data here and take a look at the sample data set that I have. But I've also created a database to put in all my data, so it's easier for me to stitch all of them together. Here's the database. Everything is in the raw schema, all the raw data sets here. This airline delays table is basically the flight delay data set, which you saw earlier. I can preview the data. Each row here represents a flight from a departure airport to an arrival airport for different carriers. So we have United Airlines, American Airlines, KLM. You can see many other airlines as well, down to even the flight numbers and the exact time of arrival and departure, and also whether these flights are on time, delayed, or early. This column here is really important because it's used as the label to train the classification problem. So let's take a look at our data set here. We have 4.4 million rows across 580 different carriers for the month of October in 2022. I also uploaded the public data sets from Meteostat. So just to show you where I took the data from, this is the data here, and according to their website, they are the weather and climate database that provides detailed weather data for thousands of weather stations here. I use mainly two APIs, the bulk data to curl hourly weather data sets for the airport locations for that particular month and year. And then I use the Python library to get a weather forecast data. So let's take a look of the data sets which I downloaded from Meteostat website. You can see each of them has a different ID here. So this is the weather station. I have about 2,000 files here, and I can easily just copy that into Snowflake using this simple single command here. So this matches the weather station ID to the airport identified by this ICAO code here. This also shows how easy it is to combine data sets of different types. I have CSV files, I have JSON files, and I have data sets, table data sets taken from the marketplace. I can combine all of that in Snowflake. Next thing I want to do is to stitch the weather data with flight delay data set, and I can do that easily in Snowpark. So first in Snowpark, let me import the relevant libraries first, create a Snowpark session. So now I'm connected to a warehouse here with a database, airline database on the raw schema, connected as a user here called Maverick. Next, I want to do some feature engineering. So let's connect to the airline delays table here. And I want to remove any airports where there is no weather data. So basically the station ID is null. And also any flights that do not have any valid departure or arrival time. Then I want to combine that with the weather data. Select the relevant features that I want. Perform some transformations here. So I want to extract the day of week, Monday to Sunday, from the arrival time as features, and also the hour of arrival here. And for the target, to make things simple, I want this to be a binary classification problem. So I combine the status where it is on time or early as not delayed. And of course, the other status is delayed. So that's just 2. And let's take a look at the data. This pushes the computation into Snowflake. So let's take a look at Snowflake's site. I have here the query that is sent from Snowpark. So you can see this long list of SQL query that is translated automatically by Snowpark. You didn't have to write all this. And you can also look at the query profile. You have some visibility on how that query was executed. Let's go back to Snowpark. After the feature engineering, I did some exploratory analysis, remove some null values or combine some of the null values into a different category. And then on the training side, I train all the models in a stored procedure here. So these are the parts where I perform some pre-processing of the data, fit the data into a model. I uploaded the model into a temp folder in the Python sandbox environment here. So I basically dump the model and put that into a staging location here in Snowflake. The reason why I'm doing this is so that I can retrieve the model later on for further analysis. And I register the stored procedure in Snowflake and call the stored procedure for training. Then in order for me to perform further analysis, I got the models back here from the stage, load that in and compute the accuracy metrics using AUC. So the AUC is about 0.8, which is fairly well considering the fact that I only used weather data. And then next few lines is generating explainability from the models. So I used feature importance to give me a list of factors that correlates with flight delays. And within each factor, find out how the changes within the factor affects the flight delay. But instead of looking at all this here in a notebook, I save that as tables in Snowflake, so I can use Snowsight to visualize this. Let's go to Snowsight. I created one dashboard to look at these predictors. So I have one chart here that shows you the main predictors for flight delay being aircraft type, number one, followed by pressure and relative humidity and arrival time. And if we drill down into aircraft type, these two main aircraft codes here, one is a propeller plane and one is built in the 1980s. So it makes sense because these are older planes that require more maintenance and that causes flight delays. Next, we have relative humidity. That's the amount of moisture that the cloud can hold before it rains. So it makes sense if it is more humid because it tends to rain and rain causes flight delay. But what I didn't know was when the air is too dry as well, it causes flight delays. And on the arrival time, peak delays happen between 2 to 4 a.m. A second dashboard was created as well. This is basically just a PI dashboard that shows three things. One, most of the flights delayed for this particular carrier is between Bangkok and Phuket and vice versa. But as a percentage of flights delayed, most of the flights between KL and Bangkok are delayed. So as you can see here, almost 80% of the flights between these locations are delayed. But if you're looking at the amount of delay, if you're taking a flight between Shanghai and Bangkok, chances are it will be delayed on an average of 300 minutes or 5 hours, which is way higher than the rest of the routes. And this just shows you the trends of the delays on a daily basis for that particular month. Let's go back to the notebook. Finally, we have a prediction that's being done by creating a UDF so that the inference is done right on Snowflake without moving any data out. This is a Streamlit app that was deployed on Streamlit Cloud. It's serverless. You don't need to set up any app server and it scales automatically with Snowflake. Also, the widgets are built easily using Streamlit wrappers that accelerates the development time a lot. This app showcases mainly three things. One is a map of flight delays. Each path here shows a particular flight number and arrival airport. This is the exact flight number between Bangkok and Stockholm for Thai Airways. Red represents delay, green means no delay. So you can see on average, flights between Bangkok and Europe were delayed. And you can also select a different arrival airport, let's say Amsterdam. The second part is a use case for an operation analyst to look at the list of flights that are delayed, for example, between Singapore and Bangkok. The system then goes and queries for alternative connecting flights with available seats that passengers can be routed to. This improves customer satisfaction by providing proactive support. The third part here is a what-if analysis, where you want to investigate whether a flight that arrives in Frankfurt Airport on 21st of April at 9 p.m. on a A320 flight. And instead of punching the weather data one by one, you can call the weather forecast API. In this case, it's using the Meteostart API as well that pulls in the weather forecast in real time. And you can then make a prediction whether this particular flight will be delayed or not. So this flight is going to be on time or early based on the model. Let's take a look at the query history as well. You can see that when I make the prediction, it calls the UDF in Snowflake, passes in the parameters in to make the prediction. Finally, I created a tag to monitor the warehouses used for this project, which is basically two warehouses. One is used for the development by the data scientists, and the other is used for production for making the predictions. And you can see here total costs for the last 1 week for this project And you can also see what is the cost associated for each warehouse. So hopefully this gives you a good idea of an end-to-end solutions for flight delay prediction using data obtained from the marketplace, stitch that together with weather data set, perform some transformation, and build a machine learning model on Snowpark, and also a Streamlit application that provides visualization and interactivity with the data. And finally, the ability to monitor the entire consumption running Snowflake.
Thanks for watching today. Please leave any questions or comments below.